Power Theorem number 1. Chord Chord Power Theorem. Let us read the theorem. If two chords intersect in the interior of a circle, then the product of the measures of the segments of one chord is equal to the product of the measures of the segments of the other chord. In this circle, the two chords are chord AB and chord CD. They intersect at point E, which is in the interior of the circle. According to the theorem, AE times BE is equal to CE times DE. We are going to prove this using a two-column proof. For our given, we have chords AB and CD intersecting at E. Prove AE times BE is equal to CE times DE. In the first column, we are going to write the statements, and in the second column, the corresponding reasons. For our first statement, we write the given data. Chords AB and CD intersecting at E. The corresponding reason is of course given. And then for our second statement, we are going to draw segment CA and segment BD. The reason, through 2 points, there is exactly one line. There is exactly one line through point A and C, and segment CA is a part of that line. There is exactly one line through point D and B, and segment BD is a part of that line. Angle CAB is an inscribed angle, and the intercepted arc is arc CB. Angle BDC is also an inscribed angle, and the intercepted arc is arc CB. These two angles intercept the same arc. Therefore, they are congruent. So for our third statement, we write angle CAB is congruent to angle BDC. The reason, if two inscribed angles intercept the same arc or congruent arcs, then they are congruent. This is the angle AEC, and this is the angle DEB. Notice that these two angles are vertical angles, and therefore they are congruent. So for our fourth statement, we write angle AEC is congruent to angle DEB. The reason, vertical angles are congruent. The two angles of triangle AEC are congruent to the corresponding two angles of triangle DEB. These are angle CAB and angle BDC are congruent, and then angle AEC is congruent to angle DEB, as we said in statement number 4. So we can say that triangle AEC is similar to triangle DEB. So for our next statement, we write triangle AEC is similar to triangle DEB. And the reason is AA similarity postulate. AA here means angle, angle. So we can write the proportion CE over AE is equal to BE over DE. Or this can be written as CE as to AE is equal to BE as to DE. In the study of ratio and proportions, AE and BE are called means. CE and DE are called extremes. The product of the means is equal to the product of the extremes. So, AE times BE is equal to CE times DE. The reason for statement number 6 is corresponding sides of similar triangles are proportional. For our next statement, we can write AE times BE is equal to CE times DE. The product of the means, these are the means, AE and BE is equal to the product of the extremes. The extremes are CE and DE. So the reason, law of proportion. The product of the means equals the product of the extremes. Find the value of x. Number 1, in this circle, chord AB and chord CD intersect at point E, and point E is in the interior of the circle. So we can apply the chord chord power theorem. AE times the BE is equal to CE times DE. So 5 times x is equal to 6 times 10. Let's write that. 5x is equal to 6 times 10. So this is now equal to 5x is equal to 60. Divide both sides by 5. X is equal to 12. So the value of x is 12. If this is 12, 12 times 5 is 60. 6 times 10 is 60. The products are the same. So the value of x is correct. Number 2. In this circle, the chord GH and FE intersect at point I, which is in the interior of the circle. So we can apply the chord chord power theorem. Fi times the EI is equal to GI times HI. So x times the 3x minus 2 is equal to 2x times x plus 2. Let us write that. X times the quantity 3x minus 2 is equal to 2x times the quantity x plus 2. We can get rid of the parentheses by applying the distributive property of multiplication. X times 3x is 3x squared. X times negative 2 is negative 2x. 2x times x is 2x squared. 2x times 2 is 4x. Transpose 2x squared to the left side. Change its sign from positive to negative. Transpose the positive 4x to the left side. Change its sign from positive to negative. So we have now 3x squared minus 2x squared minus 2x minus 4x is equal to 0. This is now equal to x squared minus 6x is equal to 0. There is a common factor here, which is x. Factor it out. So we have now x times the quantity x minus 6 is equal to 0. Equate each factor to 0. X is equal to 0 or x minus 6 is equal to 0. Solve for x in x minus 6 is equal to 0. So x is equal to 6. The value of x is 6. We disregard 0 as a value of x because if we substitute 0 for x here, this segment will cease. Let us check. This is the 6. 3 times 6 is the 18. 18 minus 2 is the 16. 16 times 6 is equal to 96. 2 times 6 is the 12. 6 plus 2 is 8. 8 times the 12 is also 96. The product here is 96. The product here is also 96. So the value of x is correct. X is equal to 6.